Paper 1, June 2017. A fairly straightforward one, this. Sample of titanium, you've got different isotopes. Some particles mass 46, some mass 47, some mass 48, some mass 49. Sometimes one of the abundances is missing, so you need to do 100% take away the other percentages to find out the missing abundance. But this one is fairly straightforward. So first of all, you imagine there are 100 particles in the sample. You always do that, it helps with the maths. And then there are 9.1 out of the 100 particles, mass 46. You find the mass of those by multiplying those two numbers together. Multiply 7.8 by 47 to find out the mass of 47 particles in the sample. Do the same thing for 74.6 multiplied by 48 to find the mass of the 48 particles in the sample. And 8.5 multiplied by 49 to find out the mass of 49 particles in the sample. Don't be worried by m divided by z, by the way. M divided by z is the mass of a particle divided by its charge. And in the time of flight mass spectrometer, particles have charge plus 1. So mass divided by 1 is just the mass of the particles. Add them all together and you'll find out the mass of all the particles in the sample, 4782.5. To work out an average, divide by the number of particles in the sample, which we decided is 100. 47.8 is your average mass, and it even tells you that it wants it to one decimal place. That's straightforward. You've not even got to worry about how many significant figures and things to put it to. Write an equation including the state symbols to show how an atom of titanium is ionized by high energy electron impact. Electron impact is where you bombard the sample with high energy electrons, and you just knock off an electron from a gaseous from the atoms in a gaseous sample. So I've got titanium atoms gaseous, bombarded with high energy electrons. It's going to remove an electron from each of the particles to make Ti plus gaseous, and there's the electron. Which one will hit the detector first? The lightest, so 46 is lighter than 47, 48 or 49. So a particle with a mass 46 will hit the detector first. And then finally, calculate the mass in kilograms of one atom of 49 titanium. So the mass number is 49, so that's the mass of 1 mole rather. To find out the mass of one particle, you divide by Avogadro's number, and it gives you that in the question, 6.022 times 10 to the power 23. So that gives you the mass of one particle, and then you need to divide by 1,000 to get it into kilograms. Odd question this. The clue again is similar to one that I've done in the previous video. You're not given Avogadro's number and you're being asked to work out the time of flight of something. If you're not being given Avogadro's number and you're given those complicated equations, you've got an easier way of doing it. You know that the kinetic energy of any particle, half mv squared, is the same for any different particle. So half mv squared for 49 titanium is the same as half mv squared for 47 titanium. So multiply both sides by 2. mv squared for 49 titanium is the same as mv squared for 47 titanium. Now what I could do is I put 49 and 47 in there. The mass should be the mass of one particle, not one mole, one particle in kilograms. So what I really should do is I should do 49 divided by Avogadro's number to get the mass of one particle, and then divide by 1,000 to get into kilograms. But I'd have to do the same to the other side, 47 divided by Avogadro's number divided by 1,000 to get it to be the mass of one particle in kilograms. So why bother? Because I'm doing the same on both sides, so I'm not going to bother. So 49v squared for the 49 titanium plus particle equals 47v squared for the 47 titanium plus particle. Now v squared is d over t, velocity is distance divided by time, but the distance of the tube, which again I don't think it's given you in the question, so there's another clue, is the same for each side because the distance of the tube isn't changing. So I've cancelled distance on each side. So I've got 49 divided by t squared equals 47 divided by t squared. If you didn't understand all that so far, all you do, if you're not given Avogadro's number, you take the mass number of a particle, 49, divide by its time of flight squared, equals the mass of the other particle, 47, divided by its time of flight squared. Just remember that, and you're there for this kind of complicated question. Time of flight for the 49, I've plugged in and squared it. Now I know what 47 divided by t squared is. Rearrange it. T squared is 9.24 times 10 to the minus 13, so t is the square root of that, 9.612 times 10 to the minus 7.